For today's lesson, we are going to discuss about mathematical system, particularly defined terms. At the end of this video lesson, you are expected to illustrate the need of an axiomatic structure of a mathematical system in general and particularly the defined terms in geometry. But before we start our lesson, let us have our pretest first. Answer the following questions. Please pause the video and play it after you are done answering. Your time starts now. Let us check your answers. Number 1, letter D. Number 2, letter D. Number 3, letter B. Number 4, letter B. Number 5, letter A. I am going to discuss to you these terms. In the previous video, I discussed about the mathematical system, which are undefined terms, defined terms, axioms or postulates, and theorems. But we focused on the undefined terms of geometry. The undefined terms of geometry are point, line, and plane. If you want to watch this video, click here. The undefined terms such as line, point, and plane were established. In this video, these terms will be used to define all other terms and figures in the study of geometry. A definition is an exact statement or description of the meaning of a term or word so that anyone using it will understand it in the same way. The reasons that we need defined terms are: we need to be precise and concise in what we say or write. Also, we need to understand each other and make sure that we mean the same thing when we say or write a particular word. Example, we have here a definition of collinear points and coplanar points. Collinear points are points that lie on the same line. Coplanar points are points that lie on the same plane. Example, points X, Y, Z are collinear points because they lie on the same line, and points A, X, Y, Z are coplanar points because they lie on the same plane. These are the following defined terms in geometry. As you can see in this figure, the lines never meet or crosses at each other. These are what we call parallel lines. Parallel lines are lines in a plane that do not intersect. A parallel line is represented by a two short vertical line. These arrowheads indicates that these lines are parallel. Now, what if the two lines intersect and form a right angle? This is what we call a perpendicular lines. Perpendicular lines are lines that intersect and form a right angle. The symbol for perpendicular to is like an inverted T. In this example, line WY is perpendicular to line XZ because they form a right angle. As you can see in this figure, points A, B, and C are collinear points, and B is at the center of line segment AC, wherein point B divides the line segment into two equal parts. A midpoint is a point on a line segment that divides it into two equal parts, the halfway point of a line segment. If B is the midpoint of AC, then BA is equal to BC, or line segment BA is congruent to line segment BC. An angle is the figure formed by two rays with common point. For example, we have here a ray BA and ray BC. They form an angle which is angle ABC. It means that this figure is an angle. As you can see in this figure, this is also an angle because it has two rays with common point A. But what kind of angle is this? This is what we call a right angle. A right angle is an angle whose measure is 90 degrees. The square corner is used to mark a right angle. Here, angle KAP is a right angle or angle A. Definition of vertical angles. Vertical angles are two angles in which the sides of one angle are opposite rays to the sides of the other angles. Here, angle HGE and angle FGD are vertical angles. And also, Angle HGD and angle EGF are vertical angles. How about this figure? Is this an angle? Yes. But as you can see, there are two angles, angle A and angle B. This is what we call adjacent angles. If two angles like A and B have a common vertex and common side, then they are called adjacent angles. Angle A and angle B are adjacent angles. Now, let us define what is a linear pair. If two adjacent angles like A and B have their non-common sides forming a straight angle or opposite rays, then they are called linear pair. We have also angle A and angle B and forming a 180 degrees, and they have their non-common sides and forming a straight angles or opposite rays. This is what we call linear pair. Definition of supplementary angles. If the sum of the measures of two angles is 180 degrees, then they are said to be supplementary angles. For example, we have here angle 1 measures 80 degrees and angle 2 measures 100 degrees. If you are going to add angle 1 and angle 2, 80 degrees plus 100 is equal to 180, then we can say that angle 1 and angle 2 are supplementary angles. Definition of complementary angles. If the sum of the measures of two angles is 90 degrees, then they are said to be complementary angles. As you can see in this figure, angle A is 20 degrees and angle B measures 70 degrees. If we are going to add 20 degrees and 70 degrees, it is equal to 90 degrees. Then, we can say that angle A and angle B are complementary angles. Another example, we have here angle C with 75 degrees and angle D with 15 degrees. If we are going to add 75 degrees and 15 degrees, their total measures 90 degrees. Then, we can say that angle C and angle D are complementary angles. Take note that supplementary and complementary angles may not be adjacent, like this figure. Next, definition of angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. If ray OB is an angle bisector, then measurement of angle AOB equals measurement angle BOC, because ray OB divides the angle into two congruent angles. Next, definition of segment bisector. Segment bisector is a point, a line, or a segment that divides the segment into two congruent parts. As you can see here in this figure, if ray KM bisect line LN, then we can say that LM is congruent to MN, because segment bisector divides the segment into two congruent parts. This mark means that LM is equal to MN. Now, let us try these following examples. Write the conclusion to complete the if-then statement. Justify your answer by using the definitions. We have here a three collinear points, J, A, and M. Given if A is a midpoint of JM, then by using the definition of a midpoint, A is the midpoint of this given. So we can say that JA is equal to AM. Another example, given if angle TSU and angle TSV form a linear pair, then since angle TSU and angle TSV form a linear pair, then by definition of linear pair, angle TSU and angle TSV are adjacent angles. Another example, if ray OM is perpendicular to line LN, then since ray OM is perpendicular to line LN, therefore angle MON is a right angle by definition of perpendicular lines. Another example, we have here angle C and angle D are complementary angles, and measurement of angle C is 53 degrees. Then the measure of angle D is, since complementary angles measures 90 degrees, then we can say that measurement of angle D is equal to 37 degrees. How? Because 90 minus 53 is equal to 37. To better understand this lesson, let us try these activities. Write true if the statement is correct and false if not.